Good morning. Today we are going to discuss normalization of tables. What is the need for normalization? Actually, when we discussed functional dependencies and design of tables, then there are a number of problems like insertion anomalies, updation anomalies, deletion anomalies, etc. etc. So, if you want to avoid these kind of anomalies, then you have to go for normalization. So, here, as far as functional dependency and database design is concerned, we are dealing with four different normal forms. They are first normal form, second normal form, third normal form, and BCNF. This is Boy's code normal form. Actually, we can have a Venn diagram for this. Suppose that this is first normal form, then this is second normal form, this is third normal form, and this is BCNF. This is BCNF, and this is third, second, and first. That means if a table has to be in Boy's code normal form, definitely that should be third normal form. If a table has to be in, or if a set of tables, a relationship has to be in third normal form, it should be in second normal form. And if it has to be in second normal form, it should be in first normal form. Then, now we are going to discuss when we say that a table is in first normal form. When we say that, when we can say that a table is in first normal form. So the definition for first normal form, first enough, a table or a relationship is one enough, a table or relationship is one enough, then every values should be atomic. That means, for example, suppose that you have a relationship like say social security number, then employee name, say project number, and P locations. Suppose that you have a relationship or you have a table here, and here social security number of the employee, that is the name of the employee, this is the project number for which he is working. Suppose that he is working on a single project and this project is in various locations, that means P locations. For example, suppose that I am going to have a table like this, and here these are the four. Then suppose that this is SSN, E name, P number, and P locations. Okay, P locations. Now suppose that social security number is the primary key here. That means this social security number of the employee is available, and he is having this employee name, and he is working for a project which is having project number this one, and the project location is this. Okay, suppose that this social security number is say 100, and his name is say XXX, and he is working for a project, say project number 1, and here this project number, this project number, this project which is having the project number 1 is in various locations like A, B, C. That means this project is running, or that is going on in 3 sites, A, B and C. Okay, A, B and C. So this is actually not an atomic value. This is not an atomic value. Why? Here this can be decomposed again into A, B and C. So these kind of attributes or attribute values are not allowed as far as first normal form is concerned. Okay, this is the social security number. This value is atomic. That means this cannot be decomposed further. What about x-axis? That is also an atomic value. P number is also an atomic value, but here P location, this is not atomic, since this can again be decomposed into A, B and C. So here I am going to have, instead of a single entry, I am going to have here A, then again 100 XXX 1 B and 100 XXX 1 C. So now this is atomic. Why? Here all the entries, all the attribute values are atomic. So yet we say that a table or relationship is in first normal form if it satisfies the atomicity of each attribute values. That means actual values of the attribute should be atomic. That is first normal form. And now we are going to discuss second normal form. Second normal form is, as I told you, if a table has to be in second normal form, then the first condition is it should be in first normal form. That means every attribute value should be atomic, and second normal form, first normal form is word atomicity, atomic values. This is concerning atomic values. That means if a table is in first normal form, if every attribute value is atomic, and second normal form, second NF is first normal form plus some condition. That means if it is in second normal form, it has to be in first normal form plus some condition has to be satisfied. That means avoid partial dependency. Partial dependency. So now in first normal form we can have partial dependencies, and if you eliminate or if you remove partial dependencies from first normal form, that table is called second normal form. For example, suppose that you have a table, a relationship R, say social security number and employee name. This is project number, hours and MGR SSN, P name. Suppose that I am going to have a table like this. This is the social security number is a primary key. Social security number determines E name. That means once you know the social security number of the employee, then definitely we can get the value of E name, because this is dependent on this. So I am going to have, that is, this one determines employee name, and social security number again determines, that means this is the social security number of the employee and he is working on this project. So social security number again determines project number. Okay, this social security number determines, and this P number determines the project name. That means this project name is dependent on this project number. This manager SSN is dependent on again on this project number. A project has a manager. So this manager SSN depends on project number. P name depends on project number, and this employee may be working on different projects. And see here the number of hours worked. This hours worked is dependent on social security number as well as this project number. That means here this social security number and project number together determines the number of hours. Okay, that means here this employee name is dependent on social security number, the project number. This social an employee can work on different projects. So suppose that the employee is working on different projects, then different entries may be there for social security number and project number. This project number, this is the manager assistant. That means manager assistant means manager is there for a project, and project name is also dependent on project number. That means these two entities, that means these two attributes, manager assistant and P name, depends on project number, and social security number and E name. This E name depends solely on social security number, and this P number depends on social security number. Actually, P name doesn't. This is not the case. P number doesn't depends on. That means this an employee can work on different projects. So this project number does not depend on social security number. Now an employee can work on different projects. So here these together, that means social security number and P number together determines hours. So see, listen here. This SSN can determine only this employee name, and the P number can determine only manager assistant and P name. This number of hours worked can be determined by SSN and P number together. So for this table as a whole, you should have SSN and P number together forms the primary key. This is the primary key for this. Okay. So if you have a table like this, then definitely you should have SSN P number. Those two terms together, those two attributes together forms the primary key. See, now this is the primary key. Now E number depends on SSN, manager assistant and P name depends on P number. That means we have a primary key, this one, but this employee name depends on a part of the primary key. That means this employee name depends on only one SSN, and manager SSN and P name depends only on project number. This hours depends on SSN and P number together. Okay. Now, if you have a composite primary key means more than one attributes for the primary key. In that case, if there are attributes which depends only on a subset of this key, that means here SSN and P number together forms the primary key. Okay, but this E name depends on a part of the primary key, that means SSN, and MGR SSN and P name depends on another part of this primary key. This is called partial dependency. That means an attribute, a non-key attribute is depending on part of the primary key, not full of the primary key. So that kind of dependencies has to be avoided. For that, what method we are going to use? We are going to split this table. Into 3 tables. That means you should have a table like SSN and E name. because this e name depends on SSN, and here SSN is the primary key. That is relationship 1. And relationship 2 is p number mtr SSN and p name. Here p number is the primary key. So relationship 1 is having SSN as the primary key, and that means e name fully depend on SSN. Here p number is the primary key, mtr SSN and p name fully depends on p number. And R3 is SSN, p number, comma, hours. That means this employee is working for this project number, and this employee is working on this project for this much hours. That means these two together forms the primary key. Now I have divided this into 3 tables. Here every non-key attribute is fully dependent on this primary key. Here every non-key attribute MTRSSN and p name fully depends on p number. And here every non-key attribute, here only one non-key attribute that is fully dependent on this. That means partial dependency means if you have a composite primary key, that means more than an attributes for the primary key, and if a non-key attribute is depends on a subset of a proper subset of the primary key, then that we call it as partial dependency. So that has to be avoided. That means the definition for second normal form is it should be in first normal form, and every non-key attribute is fully dependent on the primary key. Every non-key attribute is fully dependent on primary key, plus every non-key attribute is fully dependent on the primary key. That means if it has to be in second normal form, it has to be in first normal form. What is the condition for first normal form? If it has to, a table has to be in first normal form, then every attribute value should be atomic. That means you can't further divide those atomic values into separate atomic values. That means it is not decomposable. That is the meaning. Then if it has to be in second normal form, it should be in first normal form, and every non-key attribute is fully dependent on the primary key. That is full functional dependency. And the next session we will discuss third normal form as well as Boy's code normal form. Okay, thank you.